Welcome. In this tutorial, we are going to learn about slots. Slots contains iterable of instance data attributes which are only allowed to be accessed. And when using slots, instance method, class method, static methods, class variables are not affected by the slots. So when the slots attribute is defined, dictionary and weak reference attribute is not created for the object of that class. And dictionary and weak reference attributes can be enabled by explicitly specifying these attributes inside the iterable which is passed to the slots attribute of the class. And slots uses less memory to store attributes and provide faster attribute lookup compared to the default implementation which uses dictionary. So how does slot uses less memory? So when using default implementation which assigns dictionary, Python allocates new namespace dictionary to each instance of a class so that attributes can be assigned per instance basis after creating the object of the class, which can be expensive in terms of memory usage. But when using slots, Python shares single object which is assigned to the slots attribute with all of its instance of a class. And when storing the value for the attributes defined inside the iterable of slots, it assigns fixed amount of memory for each data attribute which is defined inside the iterable. So comparing with the dictionary implementation, it uses less memory. So let's check the default implementation which uses dictionary attribute for the object of a class. So here the point class is defined and we have created two objects, and we will examine the dictionary attribute of class and its object. So here, as we can see, the class contains dictionary attribute which contains the function, static variable and methods of the class. And if we examine the dictionary attribute for the object, it contains the instance data attribute. And if we check ID for both object, here we can see that both object contains different dictionary object. So this concludes that when creating object of a class, Python creates a dictionary object or the namespace dictionary object for each instance of the class. And if you are assigning a new data attribute to the instance, that data attribute is stored inside this dictionary object. Now when using slots, this dictionary attribute will not be there in the instance or the object of the class. It will only contain slots attribute, and we will examine its ID for the object. So here slots attribute is defined and it is assigned iterable which contains the data attributes which are only allowed to be accessed in the sense get, set or deleted. So let's create object of a class which contains slots attribute. Now we will examine its object. So as we can see here, the ID of a slots attribute for the class as well as the object contains the same object which is assigned inside the class definition. So when creating object of a class, it does not create a new object for the slots attribute. It is sharing the same object which is passed to the definition of a class. So where does it store instance data attributes value? So if we see the dictionary attribute, class definition contains dictionary attribute which stores the other class method, instance method, static method and class variable. And if we examine that dictionary, we can see that for each attribute defined inside the iterable of slot, the class definition will contain this entry for the each attribute. So here we can see for X and Y, it has created two new entry inside the class definition. So whenever you are creating an object of a class, this definition will allocate fixed amount of memory to store the values for this instance data attributes. And if you try to access dictionary attribute on instance for the class which defines slots, it will give you attribute error that object has no attribute dictionary, because the object of a class which contains slots does not define dictionary attribute by default. And when accessing the data attribute, instance data attribute, which is same as the normal class object. So using object dot data attribute name, we can access its value which is assigned to it. Now using slot, after object creation, if you try to add or modify any attribute which is not defined inside the slots, then it will give you error. So here for point object inside the slot, there is no data attribute named color. And if we try to assign a value to it, which means we are trying to create this attribute inside the object, then it will give you error saying that point object has no attribute with the given name color. So by using slot, you can avoid adding a new data instance attribute to the object of a class. Now, if the slots iterable which is assigned to the slot attribute, if it does not contain attribute which is defined inside the constructor or the init method of a class, then object of that class will not be created. So for example, here inside init method, we have defined color which is set on the instance attribute, and it is not defined in the iterable which is set to the slots. So when creating an object of a class, it will complain that attribute color is not defined. So let's execute and check. So as you can see here, it is complaining that point object has no attribute, which means for each variable or the instance data attribute which is initialized using init method must be defined inside the iterable which is passed to the slots. Otherwise, you won't be able to create an object of that class. Now we will create a class with instance method, class method, static method and class variable which define slots attribute. So here we can see class point is having slots attribute which defines x and y data attribute which are only allowed to be set on the instance of class. It also contains class variable, instance method, class method and static method which are not defined inside the iterable which is passed to the slots attribute. So they are by default accessible by the object of this class, and if it is a class variable, class method and static method which can be accessed using class. So we will see it with the example. So we'll create an object of this class which define slots attribute, and we will access this instance method, class method, static method and class variable as we normally do on the object of a class. So as we can see, we are accessing instance method, class variable, accessing class method and static method. So they are accessible as we do normally with the class defined using dictionary attribute. And if we check the dictionary attribute of a class definition, it contains definition for the each attribute defined inside the slots iterable. And if we check dictionary attribute for instance, that attribute is not defined. So we have used get attr method, so it will return default value. And if we check slots, it contains the object which is passed to the definition of a class. Now we will see you can pass any iterable to the slots attribute except string. So first we will pass a tuple object to the slot. So as we can see, it has created slots with the tuple object, and the same object is shared with the instance of a class. Next we will pass a list to the slot. So as we can see here, although the list is a mutable data structure, the same list object which is passed to the definition of a class is shared with its instance. So here instance P1 and P2 contains same object which is passed to the definition of a class point. Same way you can also pass set to the slots, and the same object is shared with the instance of that class. You can also pass dictionary to the slots, and the same object will be shared among the instance of that class. So any iterable except for string you can pass to the slots attribute. Now we will see, after defining a class with slots attribute, if you are changing the value or modifying the iterable assigned to the slots, what happens? So when changing the slots value after defining class, it does not affect the class definition. When class object is created, it creates a class level descriptor for each instance data attribute which are present in iterable passed to it at the time of creation of a class definition. So for example, here class point contains slots attribute, which is having a tuple object containing attributes x and y. So when you are executing this class definition at the time of the class creation, whatever attribute present inside the iterable, which is assigned to the slots attribute, for each attribute it will create a class level descriptor for those attributes. So after creating class definition, if you are changing the value of slots, it will not affect the class definition, or it will not modify or reassign or recreate the class level descriptor which is assigned inside the new iterable. Okay, so whatever the attributes present at the time of executing this class definition, for those attributes a class level descriptor is created. So let's see it with the example. So here, when creating class definition, the class point contains only x and y attribute, and after creating class definition we are adding one more attribute, color. Okay, and we will try to add value to this new attribute. So after assigning a new iterable to the slots attribute, first we will create object of this class. So it creates object of this point class normally, and as we have defined x and y, those attributes will be accessible. And if we check the slots attribute of class, now it contains a new iterable. And even if we check for the object of that class, it points to the new iterable assigned to it. But if we check the class definition or the dictionary of a class, we can see only x and y are defined as a class level descriptor inside the class definition of point. It does not include a newly assigned attribute color. Okay, it is only defined inside the iterable assigned to the slots. So when you are modifying it, it does not create a new class level descriptor after creating the definition of a class. So when you try to assign a value to the newly assigned iterable attribute, it will simply give you error saying point object has no attribute color. Now that we know the Python uses descriptor to define each attribute in a slot iterable, so whatever name used inside data attribute name defined inside the slots iterable, you cannot use it for the class variable. So if you are defining the attribute inside the iterable and same name is defined for class variable, it will give you error when you are defining the class saying that x is slots, which conflicts with the class variable. So when defining slots attributes inside it, the name of them must be unique with the name of class variables, because for each attribute it is defining a class level descriptor. Now we will define dictionary attribute explicitly inside the slots. Now we want to use dictionary attribute alongside the slots attribute. But before using that, we must know that when using dictionary attribute with slots, it requires extra memory compared to the normal definition of a class which uses dictionary, because we are using slots also and dictionary also. So dictionary will contain its own memory and slots will also require its own memory. So if we see the class definition for this class point, if we are defining slots with attributes, a data instance attribute and the dictionary attribute, for this attributes it will create a class level descriptor, and if we are defining dictionary attribute, it will also create a namespace dictionary for each object of that class. So it will require more memory than normal dictionary implementation of class. And lookup time may increase as now Python needs to search for attribute in slots and dictionary. So we will define class with slots, which defines a dictionary inside the iterable which is assigned to slots, and we will examine the class definition. So here we have created class, and if we examine the dictionary of a class, as we can see here, it has created descriptor for x and y, and it also contains attribute dictionary. So if we check the dictionary attribute of object, now it is enabled. So earlier we saw when using slots, these are not created. Now it is created and it contains the attribute which are not even defined inside the slots. So earlier we saw, even if you try to initialize an attribute which is not present in slot, it will give you error. But here using dictionary, we are able to initialize a variable or an instance data attribute which is not present inside the slots. So it will be stored inside the dictionary, because the class definition, as we saw for point, it does not contain the descriptor for the data attribute z. And if we access slots, it will contain same object which is passed to the class definition. So getting and setting non-slot attribute will remain same as we saw earlier. And one thing is, when defining dictionary, now you can attach new data attribute to the object because we are using dictionary. So color is not defined for this object of point class, and if you are assigning value to it, and if we are checking the dictionary, now the dictionary will contain an additional entry for newly created data attribute. And if we check slots and dictionary, both are defined for that object of a class. Now we will see slots and inheritance. So each class in a single inheritance hierarchy can have their own slots attribute defined, and they are combined in single set from that inheritance tree to check for validation when accessing attribute. So when inheriting a class with the slots attribute defined, the subclass does not require to define attributes which are present in the superclass. So for example, here class point 3D is inheriting point 2D, which defines slots with attribute X and Y. So when defining slots for point 3D, you don't need to define the attribute which are already defined in a superclass. So we will add only the attributes which are newly added for this class definition. Okay, so it only contains attribute Z. So when creating an object of this class, when you are looking up these attributes, all the classes in the hierarchy of inheritance, their slots attribute will be combined into the single set. So if you take set of this, it contains attribute X, Y and Z. So those are the attributes which are allowed to be accessed on an instance. And if you see the slots attribute, it will return only this. But when you are looking up all the classes in the hierarchy and their slots attribute are combined into the single set. Now what happens if you are redefining those attributes which are present in the superclass of that? So here we can see point 2D contains attribute X, which is also redefined inside this subclass point 3D. And after creating this class, if we check their definition or the dictionary object, if we see for the member X, which is defined in the slots for both class, we can see that for point 2D and 3D, it is creating a class level descriptor for point attribute X, which will waste your memory for the object of this subclass. So try to avoid redefining the attribute which are already defined by the superclass of this class. Now when using multiple inheritance, it allows only one class to be defining the slots attribute. And if you are inheriting multiple classes with the slots attribute defined into it, it will give you error or the type error when creating class definition. So for example, this class is inheriting from two classes which defines slots attribute. So when defining this class, it will say that type error, multiple bases have instance layout conflict. So when using multiple inheritance, only one of the many parents or the superclass defined inside this inheritance can have slots attribute. What if subclass does not define slots attribute when superclass is having slots attribute? For example, point 2D is having slots attribute for its instance data attribute, and point 3D inheriting it does not define any slots attribute explicitly. So in that case, superclass slots become class attribute to the subclass, and by default dictionary and weak reference is enabled for the subclass. So whatever the instance data attribute defined for this class will be stored inside the dictionary, and this attribute defined for the slots for the parents will be stored inside the class level descriptor defined inside this. So we'll see it with example. So we will create an object of class point3d, and if we check the dictionary of the class, as we can see, dictionary and weak reference is enabled. So whatever the data instance attribute will be created will be stored inside the dictionary. And if we check slots for this instance, as we can see, it contains attributes x and y defined for in the superclass. So when adding a new attribute, it will be added to the dictionary of that particular object. Same way, if the case is other way, if the superclass is not defining a slots and the subclass is defining slots, for example, point2d does not define slots attribute and point3d inheriting point2d defines the slots attribute. So in that case, the dictionary and weak reference attributes from the superclass will be inherited. So for the attributes which are not defined inside the slots will be stored inside the dictionary of the parents which is inherited. So for this definition, we will create again an object of this class, and if we try to add, first we will check the slots. So slots for this point3d only allows x, y and z instance data attribute, but because we are inheriting a class which does not define slots, setting a new attribute on an instance of this class with the slots attribute will allow to set this instance data attribute to the dictionary. So if we try to add a new data attribute, it is allowed, and if we check the dictionary of P3, it contains this attribute. So this attribute which is not defined inside the slots are accessible on instance because the slots attribute is not defined inside the parents. So when using slots, remember that if you are using slots, all the classes in the hierarchy needs to define slots. Otherwise, it will not give you the benefit of using slots. So that brings us to the end of the video.